Well, good evening, everyone. And how are you guys doing tonight?
I'm all
Good.
right.
Good.
I was not hit by the rocket, so I'm in good shape.
Hey,
I was
good.
looking up all day
We
trying to
got
protect my head.
Yeah,
clear skies and low humidity. It's a good night.
Yeah,
yeah,
yeah, we
yeah. A
lucked out.
little windy though. So,
Yeah,
but
it's all
we'll
right.
manage. We'll
We'll
manage.
take we'll take it.
Yeah.
All right.
So, thank you for joining us tonight. I'm Rich Ozer, and this is Gerald McKeegan and John Curry. And we're here for the Chabot Space and Science Center's weekly virtual telescope viewing. And tonight we've lucked out. We've got the right weather conditions. It's nice and dry, and it's pretty clear. So we should be able to show you a variety of objects through our 36-inch research telescope, fondly named Nellie. And it's already a little too dark to show you a picture of her, so we'll just have to look through her rather than at her. There you go. Good idea, Gerald. So the
She's
power of
there.
the
She's
power of
there.
flashlights.
Yeah.
Yeah, so a few things to mention before we get started. The Chabot Space and Science Center, as you know, has been closed throughout the COVID pandemic, but the Science Center is planning on reopening to the public in November, and we're going to be working hard to get things ready for that. So stay tuned and keep an eye on the calendar, and we'll be announcing new exhibits and getting back to our regular schedule of public viewing out on the deck and all that good stuff. Knock on wood that our situation continues to improve and does not change. I want to thank Fremont Bank, our community sponsor, for helping us and others in the East Bay community keep their programs and businesses going. And a couple other announcements we've got. You notice now that we're getting into summer. It's kind of an early summer, right? But we're getting into summer. That it's getting dark a little bit later. So starting next week, virtual telescope viewing will be starting at 9:30 rather than 9 o'clock. So if you tune in at 9 and you're still not seeing anything, it's because we're going to start at 9:30, and that will last throughout the summer, and then we'll switch back to our fall schedule when we figure out when the best weekend to do that is. So 9:30 for virtual telescope viewing from next week onward. And Gerald, why don't you talk about what we're planning later in the month on the 26th?
Oh yeah. On May 26th, very early in the morning, there will be a total lunar eclipse when the moon will be passing through the shadow of the Earth. So that will begin at 1:47 a.m. on the morning of the 26th. So for you folks who want to stay up all night, we will be live streaming it from here at Chabot. In fact, we're probably going to use more than one telescope to do this. So you'll get different views with different telescopes. The Earth's shadow actually consists of two concentric rings, if you will. The outer ring is what we call the penumbra, and it's a much fainter shadow. And the moon will begin to enter the penumbra right at 1:47 a.m. Uh, and it won't be for about an hour later that it will start to enter the umbra, which is the inner shadow. That's the shadow that's darker, much darker, and has a reddish hue to it. So we often talk about total lunar eclipse being a blood moon. Um, and it will only stay fully within that shadow for about 11 minutes. And that's because the moon is not passing through the center of the umbra shadow. It's moving across the kind of the upper part of it. So it only stays fully total for about 11 minutes and then it will move out.
You know,
Most
often lunar eclipses go a lot longer than that.
Right, right.
This will be a
Now,
short one.
now, because of our location relative to when this is happening, the moon will set before the eclipse is completely over. So we will continue to view it until about 5 a.m., by which time it will be so low in the sky that we won't be able to point the telescopes at it. The moon will still be partially eclipsed at that point, but we'll cover it as long as we can, and you will definitely be able to see totality. But you got to stay up late to do that.
It's an insomniac's dream.
Yeah. Yeah. Any astronomer will tell you that sleep is highly overrated.
That's right. Yeah. So we'll cover it for as long as we're still standing, right?
Yeah, as long as we're still awake, we can do something.
Right. So anyway, that's something to look forward. Again, that's early in the morning on May 26th, which I think is what is that? It's a Wednesday morning. I think
that's a Wednesday. Yeah.
Yeah. So stay up all night and join us, and we'll try to keep you entertained while we watch this very slow process of the moon passing through the Earth's shadow.
Great. Thanks, Gerald.
I'm working on, some good lunar jokes and things.
Yeah, we've only got a few weeks to come up with some.
Play some Pink Floyd or something.
Yeah, there we go. All right.
So, should we talk about the rocket?
Oh,
Yeah.
yes. Today
sure
was
What's left of it?
today was the sky was falling.
Yeah.
Right.
So I'm sure some
Yeah.
people are tuning in hoping that we're going to point the telescope at the rocket, the Chinese rocket booster that was out of control. Unfortunately, we're too late. That the rocket booster re-entered the atmosphere shortly after 8 o'clock our time, actually shortly after 7 o'clock our time, Pacific time, entered over the Indian Ocean near the Maldives Islands. So it's gone. It's been kind of exciting. Lots of people were watching it, and they weren't sure exactly when it was going to come down. There were predictions that it would not come down for as much as an hour or two later than that. And what was really interesting is within the window of uncertainty, there was a period when the orbital track would have taken it over the northern part of Mexico and then across the eastern half of the United States. So, there was always a chance that it might come down over the eastern half of the United States. But no, it came down much earlier and ended up coming down over the Indian Ocean. So
now typically this isn't the first time something like this has happened by any means, but typically these types of rockets have controlled reentries. It's part of the plan on
Correct.
their entire flight plan that at the very end they fire thrusters to guide them into a particular trajectory that at least predicts within a reasonable region where it'll come down. So the Chinese must have lost either communication or control of this
Yes.
rocket early on, because it's not to their benefit to allow this 22-ton piece of space junk to just come down randomly anywhere on the Earth.
I saw some talk about that actually they don't have it built into the rocket, and it
Really?
And this is the second time, actually, the same rocket.
Yeah,
and it failed the same way the first time, too.
Right. They're supposed to have the kind of control that you're talking about, Richard, to where they actually program it to re-enter over the ocean and burn up in the atmosphere at an angle such that it mostly burns up in the atmosphere, and then whatever pieces don't burn up, they fall into the ocean. But for whatever reason, this is a really big booster that they're using, and for whatever reason, they don't have control over it. So
Wow.
Now this booster was used to launch a module for the new Chinese space station. They are building their own space station, and this was to launch that module, and it was a successful launch in that sense that the module was placed in orbit as it was supposed to, but that booster then just basically fell wherever it was going to fall, and that's not supposed to happen.
No, they should talk to Elon Musk and see how to land the thing again.
Well, it's they certainly have the capability of making the electronics to do this, so it's not
right.
and by international agreement, that's what they're supposed to do. So
very interesting. So I mean, there were some notable similar incidents in the past. I mean, was it Skylab or was it Mir or was it both that had
both?
Both.
Both. Yes. Yeah. I remember Skylab. A bunch of us went up on the roof of the apartment building where my girlfriend was living, and we all stood up there wearing hard hats.
Wearing hard hats.
It ended up coming down near.
That would have helped.
Didn't they actually recover some pieces of Skylab?
Yeah. The pieces of it fell in Australia.
Yeah.
Yeah, but back then it was a good excuse for partying. This is back
of course
in the 1970s. And, then that was any excuse to have a party. So a bunch of us went up on the roof and, we're imbibing and waiting for Skylab.
I should ask, were these hard hats, were they equipped with beer cans on the side of them?
Mine wasn't. I don't drink beer. So. Anyway,
all right. Yeah, that was good. All right. So I guess it's time to move on. It's getting pretty nice and dark.
Starting to get dark. Yeah.
Yeah. So we're gonna try to give you a variety of different astronomical object types tonight, and I think we're gonna start with the Globular Cluster M3, which is still nice and prominent in the early evening night sky. So let's see if I can get the camera going.
Yeah, get the camera going, and I'll point the telescope. And
all right.
So we are using Nellie, our 36-inch reflecting telescope, and it is our only computer-controlled telescope. So when we want to go to M3, we just tell the computer go to M3, and away it goes.
Gonna do a midway point, or are you gonna try to go right there?
I probably should have, but I didn't.
No, we'll give it a shot. All right. We'll go for 30 seconds, maybe.
Arcturus is really close, so maybe you should point.
Yeah, let's do that.
Let's do that.
It'll save us some trouble.
Yeah, when you do really long moves with the telescope, we tend to not be perfect in our pointings.
Oh, there we go. Not bad. All right.
Oh, yeah. So let me center that up.
And that is the star Arcturus.
Yeah. So it's a little windy up here tonight, folks. So our seeing may not be ideal. When we say seeing, we're talking about how sharp the image will look. When it's very windy, it tends to cause a lot of turbulence in the sky, and then it's like looking at something through running water. So, all right, here we go. M3 on our way.
And you can hear the wind on our microphones, too.
Yeah.
Yeah, that's right.
Okay, we're there.
All
right, let's do a 30-second shot, I think.
So this object is not real bright, so we can't do a live view. We have to use a long exposure. So Richard is going to shoot a 30-second exposure. Meantime, I'll tell you.
It would help if I could see my keyboard, but that's all right. There we go.
Meantime, I'll tell you a little bit about this object. It's called a globular star cluster. And you'll see in a few minutes that it looks like a ball of stars out in space. It's about 33,000, maybe a little bit more than 33,000 light years away. And it's like I say, it looks like a ball of stars. The stars in the cluster orbit around the center of the cluster, and the cluster orbits around the galaxy, the Milky Way galaxy, but it orbits in a region called the halo. So if you were outside of the Milky Way looking at it, it would look like a flat disk with spiral arms in it, a central bulge. And around that disk, you would see this very faint kind of diffuse region that's more or less spherical. And that is called the halo of the galaxy. And the globular star clusters orbit in the halo. Looks like we need to go north a little bit, huh?
Yep.
Just
All right.
barely, yeah.
Yeah, just a smidge. All right. Try it again if you want to.
Sure.
So
Ready?
anyway, the stars orbit around the center. As they orbit around the center of the cluster, they orbit in highly elliptical orbits. So they're not nice circular orbits. They're very elliptical. So they go in close to the center. When they're close to the center of the cluster, they're moving very fast. But as they orbit around and then start to swing out away from the center, they slow down and eventually basically stop and then start to fall back in towards the center of the cluster. They don't really stop. They just slow down enough to where they are no longer swinging out and they start to come back in towards the center of the cluster.
There we go.
M3 is a little bit unusual in that it's a very compact globular cluster. More than half the mass of this cluster is within a region that's only 22 light years across. Now, a lot of globular star clusters are 100 light years across or even a little bit more than that. This one is much more compact. It's only about 65 light years across for the whole thing, but half the mass is within a region that's only 22 light years across. Now, it's got about 280 to 300,000 stars in it. And if you can imagine half of those stars in a space only 22 light years across, you get some idea of how crowded it is near the center of the cluster. And because it's so crowded, stars sometimes bump into each other. And that has some interesting effects. It can either strip away the outer layer of a star, or it can cause two stars to merge together. And when that happens, stars that are very old suddenly look like they're new stars. And we call those new stars blue stragglers. The stars in the cluster are all very old. They're more than 10 billion years old. Globular star clusters, most of them formed as the Milky Way galaxy was first forming. So they are very old, and because they are in the halo and not passing through the spiral arms and the disk of the galaxy, they have no source of new gases and dust to form new stars. So all of the high mass stars in this cluster formed long ago and are gone. And what remains are all the low mass stars, which have much longer lifespans. And those are the stars we see today. So M3.
Great. And so this one, I think you said, or maybe hadn't, because I was paying attention to the camera, that it's about 30,000 light years away.
33,000 light years.
33,000 light years away. So I was thinking we can give a try at looking at a nearby NGC globular cluster called NGC 5466, and it's nearby from our perspective. It's just like 5 degrees away from M3, but it's twice the distance from the Earth. And I thought it would be interesting to see A, whether we can capture it, and B, whether we notice a difference in brightness if we do capture it that seems to correspond with its, the fact that it's double the distance from the Earth. So I thought it would be an interesting thing to try.
Yeah, so it's NGC 5466, right?
5466. Yeah. And that's in the constellation Boötes.
Yep, the computer sees it. So here we go.
That's good. At least somebody does.
In the meantime, we were asked, were all these cluster stars created by the same nebula? Probably, sort of.
That's a great question. Yeah.
Yeah, the galaxy started out as this great big huge cloud of gas and dust. As it began to condense because of its mutual gravitation, it did not condense nice and uniformly. It was lumpy. And so some of those lumps may have kind of lingered out near the periphery of the cloud and formed the globular star clusters. So yes, in the sense that it formed from the original great big huge cloud of gas and dust. But as that cloud condensed, it sort of fragmented into smaller clumps, and this globular cluster came from one of those clumps.
And probably almost all of the stars in it came from the same clump, so to speak.
Right.
All right.
We got another question. Can we see Pluto tonight? And the answer is no. It's
No.
Well below the horizon yet.
Yeah, we missed out on that.
Even if we could, it's not very exciting to see at this distance. We just see it as
like a star,
a dim star among other dim stars.
Okay, so we've captured this NGC object, or some of it, and if you guys are looking on your phone, it may be a little tough. If you're looking on a computer screen, you'll see what seems to be a much fainter and less prominent object, probably because of the difference in distance. But what we'll do is take a longer exposure and see if we can bring that out.
Towards the top?
Yeah, this area right here.
Yeah, okay, so let me move you up a little bit. Okay, go ahead.
Okay, I'm going to bring this to 60 seconds. We'll see what happens.
And do you know off the top, you said it was twice as far?
It's a little less than twice. It's 52,000 light years.
Oh, okay.
And interestingly, it was discovered in 1784 by William Herschel.
Really?
So he had a pretty good telescope.
And sharp eyes.
And good eyes, yeah.
Not as good as ours, but he probably had much better dark skies,
Yeah, he definitely had dark skies.
Kathleen wants us to Arcturus.
I saw that.
Yeah, I saw that. All right, another 10 seconds here. Let's see if we get anything here.
Howard says I guess when he was a kid, he was going to go to camp, and his mother was worried that Skylab was going to fall on his head.
There we go. All right, well that's a little better, and it looks a bit more like a globular cluster.
A bit.
A bit. Well, you got to use your imagination a little bit. If I zoom in a little bit, you could see that there are in fact stars there.
Looks a little blurry. I'm guessing that's a bad because of the wind.
That's in the wind, and probably our focus isn't right on. I was hoping we would see the stripe of blue stars that are described on this thing, but I can't really tell. It's possible that they're right here, but I don't think that our viewers can see that distinction too easily.
Yeah. I'm looking at a really nice image done on Sky Safari, and I can't see the line of blue stars on there.
Yeah, all right.
So,
all right.
So where to now?
We'll move on for this. Well, it's a good time of year to look at galaxies in Leo. So what we can do is show you, well, Gerald, why don't you put it on M65, which is the first of the Leo Triplet, M65, M66, and NGC 3628. On a shorter telescope, you can get all three in the same field of view. On Nellie, we could look at them one at a time. So we'll do that and then show you a picture of all three together afterwards.
I'm going to slew over to Denebola, and we're going to sync on that. So if you want to go to live mode.
Sure.
And
there we go, down here. Yeah, so the Leo constellation is chock full of galaxies, and the reason we see so many galaxies there is because it's outside of the plane of the Milky Way from our perspective. So we're mostly looking out into deep space rather than looking towards the center of our own galaxy or through the outer arms of our own galaxy. And because of the relative lack of stars in that direction, Milky Way stars, we're able to see all of these deep sky galaxies. And Leo's kind of the galaxy hunters' go-to place for astronomy.
You wanted to do M65 first, right?
Yeah, let's just do M65. We'll take them
okay.
in order. Yep.
All right, here we go.
Okay.
All right, you are there.
Okay.
So what we're going to be looking at is actually 3 spiral galaxies, M65, M66, and NGC, what was it? 3628.
Or 28.
Yeah, 3628. And as Richard said, they're all grouped together. This is actually pretty common that galaxies occur in clusters. And
All right, there
in fact,
we go.
if you look at the large scale structure of the universe, you find that galaxies are kind of distributed in clusters and filaments, not uniformly spread out. And this is going to be a good example that you're going to see here. So your galaxy's in there.
Yeah, I'm trying to get the right amount of. There we go. That's about as good as we're going to get it on a 35-second exposure.
Yeah.
So I can go a little longer here.
So if you're new to this, if you haven't been with us before, you're probably looking at this and say, gee, I've seen pictures that look a lot nicer than that. And you would be right. And if we wanted to give you a really nice picture, you could sit here for about 2 hours while we take a whole bunch of images and Richard processes them and everything, and he could make you a really nice picture. But
we don't have that kind of time.
Yeah, those nice pictures that you see take a lot of time, a lot of effort. This object is about 35 million light years away. And like I say, it's a spiral galaxy. Probably not too different from our own Milky Way galaxy. All right. Are you doing another exposure?
Yeah, I thought I would double it and go to 60 seconds and see what happens.
And while you're doing that, Stephen mentions that the nova, the recently discovered nova in Cassiopeia, supposedly has greatly flared up in brightness a couple of days ago.
Oh, really?
Any possibility of viewing it again? We might be able to.
All right, that's better. There we go.
Well, yeah, I don't see why not. I mean, we'll do a couple other things here first.
Sure.
All right, I get a little bit better impression of it here.
Yeah, I see the announcement right here. Large brightness increase of V1405, which is the nova in Cassiopeia.
There we go. All right. That's about as good as we're going to get.
That's pretty good.
Yeah, you can see the core, and you can see a little bit of a sense of the spiral arms, and a lot brighter and denser towards the center, of course. And those stars are, of course, foreground stars here in the Milky Way. Had nothing to do with the galaxy. All right, next one, M66.
M66, all right.
Yep. And we know that 60 seconds is the right exposure, so we will start off with that once we get there.
All right, hang on just a second. All I have to do is push the right button.
Yeah.
Oh.
When all else fails.
Well, we'll slew the telescope, but it won't be a very big slew because these are all very close in position in the sky.
Okay, we're there. And in fact, after Rich has done this a few times here, we're going to show you a wide field view taken by an astronomer who spent several hours processing the images. And you'll see how they're all related to each other in the sky.
Someone wanted to know what's the third one we're going to look at, and that is going to be NGC 3628. It doesn't have an M number, but it has a new general catalog number. And I know we went through that really quickly. So.
Yeah, Joe actually answered that in text below.
Oh, there it is. Yeah,
help us out there. Thanks, Joe.
Thank you, Joe. Yep.
Answered what?
The name of the third galaxy.
Okay. Yeah.
Or the catalog number, excuse me.
Okay, let's see.
Oh, yeah. There we go. All right. So this one is more face on to us, right? So we're able to get a better sense of the shape of it and the spiral arms, and the dense core here, and arms going out like so, and coming down all the way to here.
Looks like the total brightness is a little bit brighter on this one. A little bit.
Yeah, I think so. Yeah, it's more concentrated, it seems. All right, that's our second one. And the third one, again, is going to be NGC 3628, which is a very unusual looking galaxy, I think. So
All right.
We'll see if we can see that.
NGC
3628. Yeah.
My fingers are not behaving themselves here. And GC. This itty bitty keyboard. 3628, right?
Yeah, 3628. Itty bitty keyboard in the dark.
It is lit up at least, isn't it?
Yeah, it is, but it's hard to see.
It's better than I got. Mine doesn't have a backlight on it.
Okay, here we go. And it barely moves.
Yeah, it's not going to be a big move, that's for sure. Okay, you ready?
So you're good, yeah.
All right, we'll take another 60-second shot.
There was a question by Kathleen. I guess it's a question. It says the dark areas in the galaxy, ? I'm not sure what she means by that.
Well,
what are they?
Well, what we're seeing are the spiral arms, which are density waves of stars. Basically, stars form in these waves in a galaxy, and they take on and the galaxy itself takes on a spiral shape as a result. And the area in between those arms are just areas that have not undergone as much significant star formation. So there's usually a lot of dust or just the absence of material. And it's characteristic of a spiral galaxy, and our own.
We even see that in
well.
Milky Way. Yeah.
Okay, 60 seconds. Let's see what we got here. There we go. Okay.
Yeah, that looks like it.
It's kind of hard to see, though. I'll tell you. That's kind of being an understatement here.
You're kind of not being very kind, right?
I'm not being very kind. I'm not being very kind to my own snapshot here. All right, that's about as good as we're going to get. So you could see this kind of weird, streaky shape going from left to right on the screen.
This one is very edge on.
So yeah, it's edge on. It looks like it's been disrupted at some point in its history, and because it doesn't have the usual kind of flat spiral shape to it, but it's also really hard to see, so I don't want to spend too much time on this one.
All right. You want to see all three of them at once?
Yeah, let's see that picture.
Let's see a highly processed picture of all three at once.
All right, I'm going to bump you off here and
Go for it.
Share this. And there you go. All right.
There we go. Yep. So you see what I mean about this one being a very weird one. This is the
last one that you were looking at right there.
Yeah.
All right.
So that's known as the Leo Triplet, and I was mentioning to Gerald earlier that if you flip this thing 90 degrees counterclockwise, it looks like the face in space.
Yeah.
Yeah.
Two eyes and a big smile, right?
Right.
Here's two eyes and a big smile. You need a nose right here.
All right. Well, thank you for that one. That's a good shot.
All right.
Where did that shot come from, by the way? Did it have a credit?
Oh, yeah, it had a credit on it. Hang on a second here. It's
trying to keep you honest.
Right.
Yeah. That's the image credit right there.
It's from the ESO.
Yeah. Yes.
Yeah.
And Omega Cam, whatever that is. So.
Okay. Thanks.
All right. Okay, where would you like to go now?
Well, should we show people a planetary nebula?
Yeah. M97?
Talk about those? Yeah, might as well do 97. That comes out good on this camera, and we've had pretty good success with that in the past.
All right.
And then we'll talk about planetary nebulas. Or nebulae. What's the proper plural, Gerald?
Nebulae.
All right.
Although some people want to say nebulas, but
and many would be a cluster of nebulae, right? Not a murder of nebulae.
All right, here we
go. Unless it's in the constellation Corvus, then it's a murder.
Then it's a murder of nebulae.
Oh, that's quite a leap.
Yeah, I think we're going to need a waypoint.
Yeah. All right. Well, I'll tell you what. Let me go first to a star here. Nice bright star. Go into live mode.
All right.
And there's the star, and we'll go.
And if you're so inclined to try adjusting the focus a bit, that would be okay.
All right.
I'm not sure we're going to get much better than that, but
yeah, I gotta.
Yeah, look at how it's moving around right now.
I know. Yeah. Just to be sure. So 13 and a half, 14 is our best number here. No, that's the wrong way, I think. Yeah.
We want a smaller number, right?
Smaller number, yeah. It's easy to get bigger numbers. Yeah, that's better. Good. We were pretty way out of focus before. All right. Okay.
Yeah, I think that's about as good as I'm going to do here. Actually,
yeah, that'll be nice for the planetary nebula.
Okay, so let me sync on that. And M97, here we go.
Okay.
We have a comment that windscreens for our mics would be helpful. We don't usually get a whole lot of wind up here when we're doing this.
Yeah, but
that's a good point.
Then I couldn't do my Darth Vader impression, you know. I am your father.
Okay. So planetary nebula. So planetary nebula are nebula, but they have nothing to do with planets. The word planetary in a planetary nebula is descriptive of how they look from Earth rather than illustrative or rather illustrative of their actual nature. And again, this is kind of a hard one to see.
Yeah, I want to see those owl eyes. By the way, this is also known as the Owl Nebula.
We're going to increase the exposure.
If we get the exposure right here, you might actually see why.
All right.
We have another question. I read that Proxima Centauri was flaring as well. Is that above the horizon or visible tonight? No, that is never above the horizon from the northern hemisphere up here.
But you are correct that it has been shown some flaring recently.
Let me answer one other quick question here while you're doing that. Regarding the lunar eclipse, is that early May 26th or 27th? It's the 26th. Early that morning, evening, or morning rather.
Yeah, early morning, May 26th. So stay up all night on the 25th, and after midnight, it'll be the 26th.
And if you wait till the 27th, you've missed it.
Right. So if I'm not here, it's because I can't read a calendar properly.
A likely story.
Okay, let's see what we get.
The answer is
yeah.
There's something there.
There definitely is something there. Okay. Let's see if I can get this
a lot of sky glow.
Yeah, that looks better.
Yeah. So even with this, you can see some color here. You can see that there's kind of a turquoise color to it with maybe a little bit of a red fringe around it. This was once a star similar to our sun. And it grew old and it swelled up, became a red giant, went through some various phases, swelling up and then contracting and then swelling up again. And as a red giant, it began losing its outer layers of gas. So you can imagine a star that was once maybe 1 million miles in diameter. Suddenly it's 100 million miles in diameter. And because it's so big, its gravitational hold on its outer layers is not very strong. At the same time, you've got a lot of internal winds that are being generated by convection and by radiation. And that is causing the outer layers of the star to begin to blow off into space. And that goes on for sometimes a couple 100,000 years, depends on the mass of the star. And eventually the fusion process at the core of the star stops. The star, then whatever's left of the star collapses and becomes a white dwarf. A white dwarf is a very small, dense, compact object. So if the star started out as 1 million miles in diameter, it's now maybe only 10,000 miles in diameter. It's extremely hot, but that heat is residual heat left over from the collapse of the star, not from the fusion process that drives normal stars. But the white dwarf is so hot, it emits ultraviolet radiation. That ultraviolet radiation goes out and hits all that gas that was expelled by the star while it was a red giant. That ultraviolet radiation ionizes the gas and causes the gas to glow. Now, most of that gas is hydrogen, but there is a small percentage of oxygen in the gas. But when oxygen, especially, is ionized into what we call doubly ionized oxygen, it emits a very bright turquoise color. And that actually overwhelms the color of the hydrogen. And so that's what you're seeing is this glowing oxygen gas, which is actually part of a much bigger cloud of hydrogen gas surrounding the white dwarf. And you can kind of see the white dwarf at the center.
Mhm.
And
Right over there.
See two little dark patches on either side of the white dwarf. That's just imperfections in this cloud. It is not a nice spherical bubble of gas. It does come off in bursts, if you will. So it's not a nice uniform bubble of gas, and you do have voids within it. And that's what's causing those little dark spots. And when amateur astronomers look at this, they see those dark spots and they look to them like the eyes of an owl. So this is called the Owl Nebula.
We got a question if we can see the globular star cluster Omega Centauri.
Oh.
And no, it's a little too low. It's right on the horizon right now, and that's too low for this telescope.
Are these all coming from somebody living in South America?
I'm wondering.
Well, it is possible in a couple, one time of year, which is right around now,
Yeah.
to see Omega Centauri from the Bay Area, but you have to get to just the right place to do it. There's a
in
couple
theory, right now it's just above the horizon, but I mean, just a degree or two.
We don't want to be looking close to the horizon.
Yeah, I've seen it from the top of Mount Diablo, and I've seen it from Del Val Reservoir, and I've seen it from a location in the peninsula as well. There happens to be a notch in the hills that cuts low enough where Omega Centauri is visible, but it's pretty impressive. But it isn't as impressive in the northern hemisphere as it would be in the southern.
Yeah, it's one of the bigger globular star clusters. Yeah. All right.
Yep.
Okay, we've seen the Owl Nebula. You wanted to look at a carbon star, I believe.
Yeah, we have a nice list of carbon stars that Bob Schock graciously provided us a few weeks back. And there's one not very far from where we're looking, and that is VY Ursa Majoris. And I have an SAO number if you could search on that, Gerald.
It's 15274, right?
Yep.
Okay, let's see. We are sync. Let me sync on this. Yeah.
And this one fluctuates between magnitude 5 and magnitude 7, I believe. So we should be able to see it okay.
SAO 15274, right?
15274, yep.
Yeah, it's a little bit of a ways away, but we'll give it a shot here.
Okay. Okay, let me reset this. And we'll start an exposure.
So this is a carbon star.
Good time to talk about the fusion cycle.
Yeah.
Star. Yeah.
So a star starts out fusing hydrogen into helium. So if you have a star that's maybe a same mass as the sun, maybe a little bit more mass than the sun, it'll start out fusing hydrogen into helium, and it'll do that for 10 or 11 billion years. But then it starts to fuse that helium into carbon. And if it gets enough carbon built up, you get some turbulence inside, convection going on. You start distributing that carbon around inside the star. And carbon absorbs a lot of the white light of the star, and it results in a star that looks kind of reddish or orange in color. And so we call these carbon stars. And it's just because it's got a lot of carbon in the upper atmosphere of the star that is absorbing a lot of the light that's being emitted, and it produces that orange color that you see. Now, this one is kind of orange. It's not real reddish. Sometimes when we look at some of these carbon stars, they are
Deep red, yeah.
deep red, ruby
Yeah.
red in some cases, so
Well, one
uh,
thing that's true about all of these carbon stars is they also tend to be highly variable, meaning they change their brightness over a predictable time period.
Yeah.
And the reason for that is once the helium is fusing into carbon, the star itself is inherently unstable. And it tends to bloat and then cool, and then it shrinks because it's cooled, which causes it to heat up again, which causes it to expand again. So it goes through these cycles of heating and cooling and expanding and contracting, and it has corresponding brightness changes as that occurs. And the color of the star might actually appear redder when it's in its cooler state as well. So right now it looks like this is more towards its maximum brightness rather than its minimum.
yeah,
It's actually a
yeah.
lot brighter than I expected it to be, but it certainly gives you a sense of how it differs from other ordinary stars. You saw us aiming the telescope earlier on more ordinary stars, and that are not at the point where they're burning up their helium into carbon, and those seemed white or blue.
Okay, where to now?
Well,
Um,
I just looked, and
yeah.
Cassiopeia is not going to be doable tonight. It's a way too low in the northern sky,
Oh,
and our
Uh,
dome will be in the way.
so much for
well,
that.
we could stay up until 1 in the morning and then
Right.
do it. Oh
Yeah.
well.
Well, we're already doing that this month.
Yeah, we only do that
Yeah.
once a
Yeah,
month,
yeah,
right?
yeah. We
Stay
can
up
only
too
do
late, it
that
might
once.
start getting bright again.
Yeah, that's right. Well, that was my list. So if there's something you guys want to,
Well, there's a whole bunch of globular clusters up. M5 is up right now. We could take a look at that if
let's
you
do
wanted.
that. Yeah, let's do that.
Okay, I got to get
Five's,
back down
five's great.
into.
Might need a waypoint on that one.
Yeah, I'm gonna need a couple of them probably here.
Yep.
Hang on a second here. Okay, go ahead and go to live mode.
Okie dokie.
Yeah, what time is it? Yeah,
You could go to Arcturus. That's not too far from there.
yeah.
You could arc to
No,
Arcturus.
no.
All right, that's pretty close to
Yeah, we're
center.
pretty
Very good.
close. Yeah. Okay, why don't I do that? So I'm going to head on down to Arcturus. So leave it in live mode. Are we going to be okay on cables there, Richard?
Yeah, I think we'll be fine.
Okay.
We'll find out.
And yeah, really. So we're just kind of hopping from one star to the other and readjusting the computer so it knows exactly where we're pointing the star. We have a very small field of view with this telescope, so if we're off even by a little bit, it tends to be rather noticeable. Okay, here we go. Yeah, fairly low, but
Okay, let's go to imaging, and I'll take a.
Okay, so M5 is another globular star cluster. It's a little bit bigger than M3 that we were looking at a while ago. M5 is about 28,000 light years away. Yeah, 30 seconds should be doing it. And it should be a little bit more in focus than the other one we were doing.
Yep.
We improved our focus a little bit. You know, M5 is not nearly as dense as M3 looked. It's much more spread out.
Oh, there we go.
Oh, yeah.
I'm going to shift it a little bit.
Little off center here. Yeah, give it a shot now if you want to. Oh, that's pretty good. Pretty good view, actually.
Yeah, that's great. Lots of different colors.
Yeah, focusing has definitely helped.
Yeah, probably would have helped on the other stuff we were looking at as well.
So there are about 150 globular star clusters orbiting around the Milky Way galaxy. We see more of them this time of the year because of the orientation of our solar system. If you imagine the disk of the Milky Way galaxy, our solar system, the plane of the orbit of the Earth around the sun, is not in line with the disk of the galaxy. It's actually tilted at an angle relative to the plane of the galactic disk. And also, the sun is not right in the center of the plane of the disk. It's actually a little bit above the plane, the center line of the plane of the disk. And because of that, we see at certain times we are kind of up in where we can see a lot more of what's around the galaxy, whereas at other times we're looking more into the galaxy. So this is the time of the year when we can see a lot more of what's around the galaxy. So we can see the globular star clusters, but it also means we can look out beyond the galaxy and see other galaxies. So springtime is when we see lots of globular star clusters and lots of other galaxies. Someday I'll have to make a little graphic to illustrate what I'm trying to say here. So, but that's pretty good.
To me.
Pretty good image, actually.
Yeah, that looks great.
Shoot a couple more of those, and you can process them because I know you have nothing to do with.
Well, that's true. I could just like leave it here and let it shoot.
And then next week he'll come back with some fantastic pictures.
Yeah.
That's right. All right. Sabina, well, why don't we take some questions?
I was just going to say, Sabina asks, is there any nebula that is visible with binoculars and dark skies?
Oh, yeah.
M13. Well, that's not a nebula, but yeah, M13 is visible with binoculars. M13
and M31.
M31, right?
Also, the Orion Nebula, but it's a little late for that. You'll have to wait till next year.
Well, you know, in about a month, when we have Sagittarius and Scorpius coming higher in the sky, more prominent, there's all kinds of bright nebula around those constellations that we'll be taking a look at here.
Yeah.
And the Swan Nebula, the Lagoon Nebula, the Trifid Nebula, those are all really great binocular objects. And so during the summer, there's a lot of opportunities to see bright nebula with binoculars.
Unfortunately, you have to stay up late to do it.
Well, right now you do anyway, but you do anyway, yeah, because
in the summertime,
it doesn't get dark till 9:30, you know, or 10. So
right.
Now, if you want to look at a globular star cluster, stay up until about 10:30 or so, and then to the east, the constellation Hercules is rising, and one of the most spectacular globular star clusters is in Hercules. It's called M13, And that is definitely a binocular object. In fact, if you're in a very dark sky location, you can actually see it with your naked eye. But it's an easy object to see, yeah, with binoculars, and it's easy to find. You get yourself a star chart, and you'll see that it's within a region of the Hercules constellation called the Keystone. And because of its relation to two stars in the keystone, it's a pretty easy object to find. So that's called M13. It's another globular star cluster.
Hey, I want to point out that this last image, we lucked out, and the seeing was really good.
Oh, yeah.
Yeah, so got a lot of sharp stars and a lot of nice color in that one.
Yeah, I tell you what, while you are doing that, I want to share something else with everybody.
Sure.
Some folks may be aware that the telescope we're using tonight is also part of a global network of observatories that searches for and tracks near-Earth asteroids. And one of the things we do is what we call confirmation. So a near-Earth asteroid may be spotted by an observatory. There's some survey observatories that scan large parts of the sky every night. If they spot something that might be an asteroid, they give that data to the International Astronomical Union's Minor Planet Center. And then the Minor Planet Center posts that information on their website, asking for confirmation. And if enough observatories are able to then pick up that same object, the Minor Planet Center can get enough data to calculate an orbit for it. And if they get enough data to where they know it's real and they've got a good orbit for it, then they assign a designation to it and publish what we call a minor planet electronic circular, which is basically the announcement. This new asteroid has been discovered. Here's the data, and so on. And so I wanted to share with you an MPEC, what we call a minor planet electronic circular, for an asteroid that passed very close to the Earth early this morning at about 3:30 or so this morning Pacific time. This asteroid came within 67,000 kilometers of the center of the Earth. So that's about 50,000, not quite 50,000 miles from the center of the Earth, which makes it pretty close. That's a lot closer than the moon, not quite as close as the geosynchronous satellites, but certainly pretty close. Now, it turns out this asteroid was a very small asteroid, but this is what we call a minor planet electronic circular. This is the announcement from the Minor Planet Center that says this new object, which they've designated 2021 JQ2, nice name, has a nice ring to it. And then what you see here is a list of all of the observations that were made over a period of 2 days. So the initial discovery observation was made by the Catalina Sky Survey, which is on Mount Lemmon near Tucson, Arizona. They're one of the major survey telescopes. They discover a very large percentage of near-Earth asteroids. And then over a period of 2 days, other observatories observed it. And when the Minor Planet Center decided they had enough data, then they issued this thing, and they came up and they calculated the orbital elements. So what you see right here, these are the orbital elements. This is what describes the size and the shape and the orientation of the orbit, which is an orbit around the sun, and also tells you where the object is in that orbit. You see something here called MOID, Earth MOID. MOID stands for minimum orbit intercept distance, which is how close it comes to the Earth's orbit. Not necessarily how close it comes to the Earth, but how close it comes to the Earth's orbit, so that if the Earth happens to be at that point, then that's how close it will come to the Earth. So this object, again, passed the Earth very close early this morning. Down here at the bottom of this thing, it just lists the position of the asteroid over the last few days and over the next few days, to, if you want to go back out and try to find it again, that's helpful information. But what I want to call your attention to is, here is a list of the observatories that participated in the confirmation, the discovery and confirmation of this object.
I see one I
know.
recognize.
And look right here.
Yay.
The
Keep going all the way across to G.
well,
McKeegan.
yeah.
Come on, you need the shameless self-promotion.
So we were observing this object last night, tracking it with our telescope, and so some of the observations up here, I have to find them in here. There's something right here. This is
I know
one of them right there. So
I know he's telling the truth, because I was also here at Chabot, and I saw him photographing this asteroid.
He kept hearing me say, "Put on a hard hat."
Yeah, that's right.
So anyway, we actually do this with this telescope quite often. We're either chasing after newly discovered asteroids, or we're doing what's called follow-up, where we track asteroids that have been discovered and have been cataloged, but they still need more data in order to refine the orbit. So that's what we do here. This is what the data looks like when we submit data to the Minor Planet Center. So anyway, I thought it'd just be kind of cool to share that with everybody.
Excellent.
So for a small fee, I'll be glad to tell you if one is coming near you.
You guys sell asteroid insurance.
All right. So how are we doing on those images, Richard?
Oh, good. I got
Looks
a bunch.
Like you got a bunch of them. So next week you're going to impress
we'll let this
us.
one finish. Yeah. Well, we'll see. This will be our last one that we take here.
So the good news is we weren't hit by any falling rockets today, and we weren't hit by any asteroids today. So that's
it was a good day.
Yeah, that's what makes it a good day, right? So, all right. Yeah. So let's see. Anybody else have any questions they want to shoot at us? We'll take them now. If not, we'll probably be signing off here pretty soon.
I haven't seen a whole lot. A lot of comments, a lot of good comments.
Yeah.
Yeah. Anything on YouTube?
There's a interesting one. I'm trying to understand it here. Are the stars around the edge of the image part of the glob?
Yes.
Or between Earth and the cluster?
Great question.
Yeah, not all of the stars, but a lot of the stars that you see out where there's not as many stars clustered together, those are actually stars that are part of the cluster. The stars go in close to the center, and they orbit very quickly when they're going around the center. And then as they swing out, they slow way down, and they kind of spread out when they're far away from the center. And then they all kind of come close together when they're near the center. So that's why it looks so dense at the center.
Now, some of the ones way out at the corners are probably near stars.
Yeah, like all the way out here.
Stars within the Milky Way.
Foreground stars is what I was trying to say. Yeah.
Right.
All right. Well, I think that maybe wraps it up for tonight. I don't see many other questions coming in, unless there's some we missed on YouTube.
Let's remind everybody that next week we will start at 9:30 rather than at 9 o'clock. And of course, we welcome donations. If you're on Facebook, there's a donation button at the top of the comment section. or the bottom of the comment section. I guess for some people it's the bottom and some it's at the top. You can also go to the Chabot Space and Science Center website, which is chabotspace.org. And you'll see a donate button at the top of the web page there, and you can click on that and make a donation. We will certainly appreciate it. That will help us continue to do our virtual programming. It will also help us get the facility ready for when we reopen later on in the fall. So
yeah, going to be a big deal with the merging or the opening of the NASA Ames visitor center here as well, and a bunch of interesting
and the
exhibits.
NASA experience. Yeah, there's
Yeah.
going to be a bunch of experience to actually highlight the research they're doing at NASA Ames Research Center. And NASA is going to be helping Chabot with virtual programming, also with outreach activities to local schools and things like that. So
We're really looking forward to it.
It's going to be a great partnership. Yeah. Okay, well, I think we've exhausted all the questions. So thank you, everyone. Hope you enjoyed it. We'll see you again next week at 9:30, same time. Nope, not the same time, but the same station.
All right. Same station and half an hour later.
Half an hour later.
Half an hour later, right.
Yeah, blame daylight saving time.
Right.
All right. Everybody have a good week.